We have already said in our past videos that insulation is one of the most vulnerable places of a transformer, and in fact the lifetime of a transformer is determined by the service life of its paper-made insulation. In turn, the service life of paper insulation is greatly influenced by water, which contributes to the destruction of cellulose molecules and a decrease in electrical strength. Therefore, throughout the entire life cycle of the transformer, water from the winding insulation must be periodically removed. Depending on where the transformer has to be serviced, the dehydration of the insulation is carried out with or without removing the windings. Globcore has developed technologies and equipment for drying the solid insulation of transformers, which are used in both cases. The insulation drying with pulling the windings out can be carried out in a vacuum oven. The insulation drying without pulling the windings out can be carried out using the hot air blower, the continuous transformer oil drying unit, the thermal vacuum dryer, or the vacuum water vapor freezing unit. We will show you in this video how the low-frequency heating method is implemented. It is one of the most advanced transformer winding drying methods in terms of water extraction efficiency, as well as saving time and energy. When an alternating current passes through a conductor, electrons that move in an orderly manner and at a certain speed collide with the atoms of the substance from which the conductor is made. In this case, part of the energy of the electrons is converted into heat and the conductor heats up. The idea behind the low-frequency heating method is to make heat produced controllable and to use it to remove water from the winding insulation. In order to put this method into practice, we need to use a frequency converter to convert the network 3-phase current with a frequency of 50 or 60 Hz into a 3-phase current with a frequency of 1 Hz. In this case, the value of the amplitude of the converted current should not exceed the nominal value of the current for the high voltage winding. Further, the current of already low frequency is supplied to the high voltage windings of the disconnected transformer, while the low voltage windings are short-circuited. Due to the magnetic coupling between the high and low voltage windings, a controlled current also begins to flow in the low voltage windings. As a result of the flow of low-frequency currents, the high and low voltage windings are heated from the inside to a typical drying temperature of 110 to 120 degrees Celsius. To prevent overheating, the temperature of the windings is constantly monitored during the drying process. Due to the fact that when heated by low-frequency currents, the heat source is the winding itself and the heating comes from the inside, the removal of water from the thickness of the insulation proceeds faster and more completely in comparison with other heating methods. The low-frequency heating method can be used both for drying new windings before they are installed into the transformer, and also for drying windings of aged transformers. When drying new windings, the low-frequency heating method can be used in conjunction with vacuum chambers to improve efficiency. In this case, low-frequency currents warm the windings up well, and the released water in the form of steam is removed from the chamber due to evacuation. When drying the windings of aged transformers, it is possible to use thermal vacuum drying or vacuum freezing of water vapor together with a low-frequency heating module simultaneously. This eliminates the need to pull the windings out of transformer. During the heating of the windings, water passes from the paper insulation into oil, and the oil is removed using a thermal vacuum dryer. After one drying cycle, the water content in the transformer solid insulation does not exceed 1%. The low-frequency heating method can be used to dry the windings of new or functioning transformers of any size in repair shops and in the field. High-quality drying using low-frequency heating increases the electrical strength and extends the life of the transformer's solid insulation by at least 10 years and most often more. What methods do you use for drying transformer insulation? Please, share your experience in the comments. To not miss our new videos on the topic of transformer maintenance, subscribe to the Globcore channel and receive notifications.